Welcome to another episode of DE Diaries. Today, we have an exciting discussion about our journey through differential equations. We're 7 students here to share our experiences, the struggles, the triumphs, and the unexpected realization. So let's introduce ourselves. I am Rebecca Luis Palma, along with my team.
Kit Panganiban.
Marcos Regala.
Nico Guevara.
Carlos Santiago.
Ian Apostol.
Marcela Sexon.
So, starting off with our first question, how was your journey with differential equations? How did you find course outcome 1? And which lesson in this course outcome did you struggle with the most? And what insights did you gain from it?
To answer that question, ang pinaka-natutukan ko talaga buong differential equation is yung course outcome 1. Sobrang nag-enjoy kasi ako dun sa topic kasi ramdam ko medyo solid yung foundation ko dito. So, parang bawat concept talaga nasusulit ko at naiintindihan ko ng konti or medyo buo siguro. Pero, pagdating sa homogeneous equation, medyo nangangapa ako at nahihirapan. Ang haba kasi ng proseso parang isang hakbang mo lang mali ka na, gano'n, or sira na yung buong solution mo. Pero siguro sa kabila ng struggle, na-realize ko lang din na hindi lang naman pala to about solving. Parang need mo rin siguro ng patience, strategy, at pag-intindi dun sa bigger picture. Hindi pwedeng bara-bara lang yung pag-solve, kailangan din ng diskarte at syaga. Pero at the end, natutunan ko na na kailangan ko magkaroon ng mindset para lampasan yung mga complicated problems. Basta meron akong persistent at willingness at matuto sa pagkakamali. Yun lang.
For me naman, to answer my own question, my journey with differential equation has been a blast. There are many things that I have learned and remembered from my past calculus lessons. It may have been a tough journey, but I learned a lot during that journey. Course outcome 1 was somewhat challenging because there were some terms that I have not mastered yet, and that is why I somewhat had a difficult time with course outcome 1. The lesson I struggled with the most in this course outcome was non-exact differential equations. This was because the process of doing it was long, and once you make a mistake in one of the steps, everything else will be wrong. Insights I've gotten from these lessons are to be careful and always double check on each step to see whether you are correct or not to have the final answer.
Well, in my case naman, my experience sa DE has been a mix of challenges and small wins. CO1 was manageable overall, but I struggled the most with Bernoulli equations sa CO1. The nonlinear form made it tricky at first, especially when trying to figure out the right substitution to make it linear. But after a lot of trial and error dun sa mga problems na sinolve, I started to see and realize how these equations apply to real-world problems like exponential growth and decay, which is isa sa mga last topics na mga pag-aaralan namin sa DE. The biggest takeaway for me is that the problems can seem more complicated than they actually are, but with the right approach, or sa case na to is the right transformation, they become much easier to solve and work with. That's all.
Okay guys, moving on, what key takeaways did you get from CO2 and what challenges did you face? Start it off, Marcus.
Thank you. In CO2, I learned key techniques for solving differential equations, but I struggled with Laplace and inverse Laplace transforms. Exams were challenging due to difficulty recalling transformation rules under pressure. I realized I needed to focus more on understanding concepts rather than memorization.
For me, I found Laplace transform especially useful for solving initial value problems efficiently. However, I struggled with long computations and ensuring accuracy in inverse transforms and correctly applying methods to equations. Despite the challenges, Cengage helped me in developing my knowledge in these concepts and improving my problem-solving skills in engineering applications.
In my case, studying differential equation was a challenging yet fulfilling experience. I learned different methods for solving the equation. However, I faced difficulties in choosing the right approach, maintaining the correct answer, and managing my time during the exam and Cengage assignment, especially with complex problems. Through consistent practice and improved problem-solving strategies, I was able to overcome these struggles, developing patience, persistence, and strong analytical skills.
Okay, so third question natin actually. Beyond the lessons covered, what new perspectives or realizations did differential equation give you? So ako na lang mauna para dito sa question na to. Personally, yung realization ko na bigla na lang ako tinamaan is how the differential equations and their concepts accurately predict concerning the principles of growth and decay sa buhay natin. Ngayon, now, what's unique about it? Well, it's how it lives alongside us through life and death situations. Sa ayaw at sa gusto natin, mamatay man o mabuhay, may differential equation na nangyayari. The use of growth and decay for any time-bounded object in our current universe can be accurately calculated and predict the potential future birth. For example, yung pinaka-current event na nangyari before is yung pandemic, the COVID-19 that started back in 2019. Well, they predicted the upcoming future for its exponentially growing virus and its own lifespan, well, yung virus, that can be even calculated using the differential equations, which is angas, diba? So, sino pa ba ang gusto sumagot sa question na to?
So, ako para sa akin, DE showed me how math models real-world systems, kagaya nung sabi mo, like with the growth ng pandemic sa COVID-19. And we studied that also from circuits to population growth. It reinforces systematic problem solving and the power of Laplace transforms in simplifying calculations and yung importance talaga ng patience and precision in handling and tackling complex problems.
And for me, studying differential equation made me realize how important math is. It helps me to predict and improve systems, like building strong structures or making machine more efficient. I saw how engineers use this equation to solve real-world problems, but I also found them challenging and time-consuming. Despite the difficulties, I learned the patience and a step-by-step approach are the key for solving complex problems.
So, since we've talked about the couple course outcomes in DE and the other topics, out of all the topics in differential equations, which one stood out to you the most and why?
Thank you sa interesting question, Rosella, no? So, sa lahat ng topics ng differential equations, parang yung nagmarka sa akin, kasi nahirapan ako dun siguro, is yung annihilators. Dahil sa pagiging systematic and yung approach ng pag-solve ng non-homogeneous differential equations. Sa halip na gumamit ng mas komplikadong pamamaraan tulad ng variation of parameters, ang annihilator ay method na nagbibigay ng mas diretsong solution sa pamamagitan ng pag-apply ng tamang differential equator para mawala yung forcing function. So, dahil dito, nagiging mas structured ang proseso ng pagsasolve na hindi lang nakakatipid sa oras kundi napapadali rin yung pagsusuri sa equation mismo. Ang ganitong klase kasi ng pamamaraan, nagpapakita ito kung paano maaring i-leverage yung mga properties ng differential operators para mapadali ang analysis at computation. Kaya talaga naging isang mahalagang konsepto ito para sa akin.
Actually, I agree dun sa sinabi ni Rebecca. Para naman sa akin, actually, may na-realize din ako dun sa previous na sinagot ko. Aside from yung growth and decay ng differential equations, I think another interesting concept would be the linear and the non-linear differential equations, as both these linear and non-linear differential equations are interesting in their and unique in their own way. Bakit? Well, linear differential equations muna are more organized and predictable, making them easier to solve with well-known methods. Simple lang naman, diretso yan. Linear. They exist in a variety of fundamental applications, including electrical circuits and simple harmonic motions. Non-linear naman are more notable in their complexity and importance na din sa buhay natin, actually. Unlike linear naman, they show a less predictable, medyo chaotic naman siya. However, complicated din in their own unique ways, which models complex systems na yung mga weather patterns na hindi naman natin basta-basta sabihin na uulan bukas, mainit bukas. And kasama din dito yung population development and mechanics na din. Their unpredictability and the complexity of their solutions make them more appealing and mas maanga siyang aralin para sa akin.
For me naman, Laplace transforms were really the most interesting topic in differential equations. They simplify solving differential equations by converting them into algebraic equations, which is a total game changer. Parang Kobe Bryant lang ba? This method makes complex problems much more manageable and efficient. At saka sa Laplace transforms, they have real-world applications in engineering, which will be valuable as I pursue a career in mechanical engineer. Their practicality and usefulness makes them even more exciting to learn.
Sorry, Chappy. So, for the next question. Which lesson from DE would benefit you in your chosen engineering program? So, paano, how, and why?
Para sa akin, madami naman mga lessons or topics na pwedeng mag-benefit sa chosen program ko. Pero for me, Laplace transforms will help me as a mechanical engineering student by simplifying complex differential equations in dynamic systems. Essential siya in analyzing vibrations, heat transfer and control systems, making problem solving more efficient. Understanding Laplace transforms will allow me to model and predict system behavior, which is also crucial in real-world engineering applications.
Sa akin naman, as an aspiring computer engineer, it will be us shaping both hardware and software applications sa future. In doing circuit analysis sa mga susunod na mga courses na ito-take namin, yung mga natutunan namin sa first and second order differential equations will help us understand how voltage and current change over time in components like resistors, capacitors, and inductors, which are essentials for designing stable power systems, processor, and signal filters. These equations will help us make circuits more energy efficient, reduce signal distortion, and keep our systems running smoothly. Whether it's a simple microcontroller, a high-performance processor, or sarili naming Megatron. Mastering them means na kaya pa namin mag-innovate ng better and more reliable services and devices, which is a huge deal for anyone na magte-take na computer engineering katulad ko sa college.
For me naman, definitely Laplace transforms and growth and decay concepts will really be useful in mechanical engineering. Katulad nga ng sabi ng Marcus kanina, Laplace transforms make solving complex differential equations much easier, especially in control systems and signal processing where we analyze system behavior efficiently. Sa growth and decay equations naman, it is also important in areas like material degradation, heat transfer, and population modeling in engineering applications. Since sa amin, sa mechanical engineer, it involves a lot of real-world problem solving, mastering differential equations will be a huge advantage.
Before the end of our podcast, our journey through differential equation has been both challenging and rewarding. We faced difficulties in grasping certain concepts, managing time during exam, and ensuring accuracy in problem solving. However, this struggle taught us the importance of patience, precision, and deeper understanding of the mathematical principles. Beyond the technical skills, he gave us new perspective on how mathematics shape the real world and engineering application. The lesson we've gained will be essential in our future career, helping us think critically and solve complex problems with confidence.